Welcome back to the channel. Today's episode is going to be different and potentially the most valuable one for your career. We're diving deep into system design interview strategy. Let's start with a fundamental question that most candidates get wrong. What is the interviewer actually looking for? Here's what it's not about: building a perfect system or knowing every single technology under the sun. I've seen brilliant engineers bomb these interviews because they got lost in implementation details or tried to showcase every piece of knowledge they had. The real goal? The interviewer wants to see how you think. They're assessing 4 key areas that separate junior from senior engineers. First, your scalability mindset. Can you think beyond a single server and a simple database? Do you naturally consider what happens when you go from 100 users to 100 million users? Second, trade-off reasoning. Every architectural decision involves trade-offs. Can you identify them, weigh them, and make informed choices? This is where experience really shows. Third, communication clarity. Can you explain complex technical concepts in a way that makes sense? Remember, you might be explaining your architecture to product managers, executives, or engineers from different teams. Finally, prioritization under pressure. In a 45-minute interview, you can't design everything perfectly. Can you focus on what matters most and make progress systematically? Here's the key insight that changed everything for me. It's not about perfection, it's about structured problem solving. Show them your process, and the technical details will follow naturally. Now, let me give you the framework that turns a chaotic 45-minute conversation into a structured showcase of your abilities. Step 1. Clarify the problem. This sounds obvious, but you'd be shocked how many candidates jump straight into drawing boxes and arrows without really understanding what they're building. Spend 3 to 5 minutes here making sure you and your interviewer are on the same page. Step 2. List requirements, both functional and non-functional. Functional requirements are what the system does. Users can post tweets, upload photos, send messages. Non-functional requirements are how well it does it. Can it handle 1 million users? Does it need 99.9% uptime? Step 3. Draw high-level components. This is your architectural skeleton, the major services, and how they connect. Keep it simple at first. You can always add complexity later. Step 4. Deep dive into 1 or 2 areas. This is where you show mastery. Pick the most interesting or challenging component and go deep. Maybe it's your database design. Maybe it's your caching strategy. Maybe it's how you handle failover. Step 5. Identify bottlenecks, trade-offs, and improvements. This is your victory lap. Show that you can think critically about your own design and identify where it might break or how it could be improved. The magic of this framework? It works for any system design question, whether they ask you to design Twitter, Uber, or a completely novel system you've never thought about before. Let me share the questions that separate experienced engineers from newcomers. These aren't just random questions. Each one helps you anchor your assumptions and design the right system. First, who are the users? Are we talking about consumers like you and me, or enterprise users? Internal employees or external customers? Different user types have completely different requirements for complexity, security, and user experience. Second, what's the expected scale? This is crucial. Are we designing for 1,000 requests per second or 1 million? 1 gigabyte of data or 1 petabyte? The architecture for a startup and the architecture for Google are completely different beasts. Third, what's the SLA? Service level agreement. How fast does it need to be, and how reliable? 99% uptime sounds good until you realize that's 3.6 days of downtime per year. 99.99% uptime? That's 52 minutes per year. Huge difference in complexity and cost. Fourth, any constraints? Are we limited to certain cloud providers? Do we need to support mobile apps? Are there regulatory requirements like GDPR? Constraints shape your entire architecture. Finally, is it read-heavy or write-heavy? This determines your database choices, caching strategies, and overall architecture. Twitter is read-heavy, lots of people reading timelines. Banking systems are write-heavy. Every transaction must be recorded accurately. Here's the pro tip. Don't just ask these questions, but explain why you're asking them. Say something like, I want to understand the scale because it affects whether I need to consider sharding the database. This shows you're not just following a checklist. You understand how requirements drive design decisions. Now, let's talk about the visual component, drawing your architecture. This is where a lot of engineers get nervous, especially if they're not used to whiteboarding. But here's the secret. It's not about artistic ability, it's about clear communication. Start with the basic flow. Client connects to API gateway, which routes to your services, which connect to your database and cache. This is your foundation for almost any system. Think of it as the skeleton that you'll add organs to. Then add your supporting layers based on what the system needs. Caching for performance, load balancing for reliability, queue systems for asynchronous processing, CDN for global content delivery. Don't add everything, only what serves your specific requirements. Here's something most candidates mess up: labeling and arrows. Every box should be clearly labeled. Every arrow should show the direction of data flow. If I can't understand your diagram without you explaining it, you've lost the interview. But here's the most important tip. Always talk while drawing. Don't just silently sketch for 5 minutes. Narrate your design as you create it. Say things like, I'm putting a load balancer here because we'll need to distribute traffic across multiple app servers, or I'm adding Redis as a cache layer to reduce database load. This narration serves two purposes. It helps the interviewer follow your thinking, and it helps you catch mistakes before they become problems. I've seen candidates realize they forgot authentication or error handling just by talking through their design out loud. Here's where good candidates become great candidates, choosing the right area to dive deep and then actually demonstrating mastery. The key word here is relevance. You want to pick the component that's most critical to your system's success. If you're designing a social media platform, maybe you go deep on the feed generation algorithm or the database schema for handling relationships between users. If you're designing a ride-sharing app, maybe you focus on the matching algorithm or the real-time location tracking system. Let me give you some concrete examples of what going deep looks like. For database schema design, you'd show the actual table structures, discuss indexing strategies, maybe talk about how you'd handle data migrations. For rate limiting, you'd explain the token bucket algorithm, discuss where to store the counters, talk about distributed rate limiting challenges. For caching, you might discuss cache invalidation strategies, cache warming, or how to handle cache stampedes. For partitioning and sharding, you'd explain your sharding key choice, how to handle cross-shard queries, what happens when you need to reshard. Here's the mistake I see constantly. Candidates try to go deep on everything. That's impossible and counterproductive. Pick 1 or 2 areas where you can really shine and demonstrate expertise. Show that you understand not just what to do, but why you're doing it and what could go wrong. The interviewer should walk away thinking, this person really understands distributed systems, not this person memorized a bunch of buzzwords. This is where senior engineers separate themselves from the pack. demonstrating that you understand every architectural decision involves trade-offs and that you can reason about them intelligently. Think in terms of constraints and choices. When you choose SQL over NoSQL, what are you gaining and what are you giving up? SQL gives you ACID transactions and complex queries, but NoSQL gives you flexibility and horizontal scaling. Neither is inherently better. It depends on your requirements. Caching is another great example. Adding a cache layer reduces database load and improves response times, but now you have to deal with cache invalidation, increased complexity, and potential consistency issues. Again, trade-offs. Let me give you a template for how to present these trade-offs. I chose Redis here for sub-millisecond latency and high throughput, but if strong consistency was critical, say we were dealing with financial transactions, I'd consider using Postgres with proper indexing instead, accepting the higher latency for guaranteed consistency. This shows several things. You understand the technical characteristics of different tools, you can connect technical choices to business requirements, and you're thoughtful about when to optimize for what. Here's another example. I'm suggesting eventual consistency here because user social feeds don't require immediate consistency. If a post takes a few seconds to appear in all feeds, that's acceptable. But for something like account balances, I'd choose strong consistency even if it means higher latency. The CAP theorem is your friend here. Discuss the trade-offs between consistency, availability, and partition tolerance. Show that you understand you can't have all three perfectly, and explain which ones you're prioritizing and why. Let's talk about the details that signal you've actually built production systems, not just study them. These are the mentions that make interviewers think, this person has been in the trenches. First, monitoring and observability. Mentioning Prometheus for metrics, Grafana for dashboards, or the Yelk stack for logging shows you understand that building the system is only half the battle. You need to be able to monitor and debug it in production. Deployment and infrastructure mentions also carry weight. Talking about Kubernetes for container orchestration, Docker for containerization, or CI/CD pipelines shows you think about the entire software lifecycle, not just the code. Security should be woven throughout your design, not an afterthought. Mention rate limiting to prevent abuse, authentication and authorization strategies, HTTPS everywhere, input validation, and SQL injection prevention. These aren't fancy, but they're essential. Disaster recovery and failover strategies are huge maturity signals. Talk about backup strategies, how you'd handle database failovers, what happens if an entire data center goes down. Most candidates forget about these until asked directly. But here's the crucial point. Don't just name-drop tools. Explain why you'd use them and what problems they solve. Saying, I'd use Kubernetes doesn't impress anyone. Saying, I'd use Kubernetes for container orchestration because it handles service discovery, load balancing, and automated failover, which reduces operational complexity as we scale. That shows understanding. The goal isn't to mention every tool you know. It's to show that you think holistically about production systems, including the operational challenges that happen after you ship the code. Time management can make or break your system design interview. I've seen brilliant engineers run out of time before they could showcase their best thinking, and I've seen average engineers get great results by managing their time well. Here's the timing breakdown that works. Spend 0 to 5 minutes clarifying the problem and scope. This feels slow, but it's an investment. Getting clarity up front prevents you from solving the wrong problem for 40 minutes. Minutes 5 to 15 should be your high-level architecture. This is your big picture, the major components, and how they connect. Don't get bogged down in details yet. You're laying the foundation. Minutes 15 to 25 are for your deep dive. This is where you show mastery by going deep on one or two critical components. This is your time to shine technically. Minutes 25 to 30 are for identifying bottlenecks, discussing trade-offs, and wrapping up. This is where you show you can think critically about your own design. Here's what kills candidates: spending 20 minutes drawing every single microservice with perfect detail, then running out of time before they can discuss any trade-offs or show deep thinking. The interviewer doesn't need to see every service. They need to see how you think about complex problems. Another time killer: getting stuck on one small detail. If you can't remember the exact syntax for a Redis command or the specific configuration for a load balancer, just say, "I need to look up the exact syntax, but the concept is," and move on. The interviewer cares about your architectural thinking, not your ability to memorize documentation. Practice with a timer. Seriously, do mock interviews where you force yourself to stick to these time boundaries. It feels artificial at first, but it becomes natural with practice. Let me leave you with the insights that will transform your system design interviews. These come from conducting hundreds of interviews and coaching engineers at all levels. First, structure beats speed every time. Interviewers would rather see a clear, methodical approach to problem solving than a frantic rush through technical details. A structured thinker who moves deliberately will always beat a brilliant engineer who can't organize their thoughts. Second, go deep on trade-offs. That's where maturity shows. Anyone can memorize that you should use Redis for caching. Senior engineers can explain when you shouldn't use Redis, what the alternatives are, and how to make that decision based on specific requirements. Third, make it a story, not a lecture. Don't just present your architecture. Narrate your thinking process. Explain why you made each decision, what alternatives you considered, what could go wrong. Take the interviewer on a journey through your problem-solving process. Fourth, practice whiteboarding and time boxing religiously. You can know every distributed systems concept perfectly, but if you can't communicate them clearly under time pressure, it won't matter. Set up a whiteboard at home. Use online collaboration tools. Do mock interviews with friends. Finally, remember what you're really doing in these interviews. You're not designing the next Netflix or Uber. You're showcasing how you think about scale, complexity, and trade-offs. Focus on demonstrating your thought process, and the technical details will follow naturally. The engineers who get offers aren't the ones who know everything. They're the ones who can think systematically under pressure and communicate their reasoning clearly. Master this framework, practice consistently, and you'll walk into these interviews with confidence. And here we come to an end to the Season 1 for System Design, making you learn about the fundamentals. Thank you all for making it a successful one. We will be coming up with another season soon. Before you go, I'd love to hear from you in the comments. If you found this video helpful, do give it a like, share it with your friends, and of course don't forget to subscribe to the channel to help us grow. I will see you in the next one. Till then, happy learning.